Okay, in this lesson we're going to talk about adding and subtracting polynomials. In order to do that, we need to go over some definitions, which will be the first few pages. The very first thing we're going to talk about is a monomial. Okay, so when we're talking about a monomial, it's a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So it can be either a real number or a variable or the product, which means multiplication of a real number, the first thing, a variable, the second thing, or multiple variables. Okay, so we're talking about monomials. So again, real number, variable, or a product. The main thing with those products is the variables have to have whole number exponents. Okay, so let's look at some examples here. So the first example, 18, this is a real number. So we consider this a monomial. The next one is x. This is a variable. So again, we consider that a monomial. Okay. This next one is a product of both of them. So a real number and a variable with whole number exponents. Okay. And then both of these are also products. Notice all of these guys have whole number exponents. Okay, whole number exponents. So remember, with whole number exponents, that means it's got to be any of the counting numbers or zero. It cannot be negative exponents. Okay, so this guy has a 1, that guy has a 1. Let's take a look at some non-examples. So the first non-example is 10 to the x. Okay. X can be any number, so we can't assume that this is a whole number exponent. So we're going to write that 10 to the x is not a whole number exponent. Okay, we also have something like 7 over x squared. Okay, when we have 7 over x squared, that is equal to 7 over x to the negative second. We'll talk about why when we get to a review of negative and zero exponents. But what you basically need to know with that is that negative exponent is not a whole number. Okay, so remember, whole numbers again are any of the positive numbers in zero. Okay, so that's monomials. The next one we're going to take a look at is binomials. Okay, so a binomial is a polygon of 2 terms. So it's basically 2 monomials either added or subtracted together. Okay, so a monomial plus a monomial. Okay, so 2 terms, and that's what we call those monomials, added or subtracted together. Okay, and remember, they're separated by addition or subtraction. Okay, so let's take a look at some examples. 3x plus 2. This 3x is a term, and the plus 2 is a term, so that is a binomial. The next one is x squared plus x. Again, x squared is a term, and the positive x is a term. And then the last one is p to the third plus q squared. Again, p to the third is a term, and a positive q squared is a term. You could also have the same thing but subtraction. Okay, in that case, p to the third would be the first term, and negative q squared would be the second term. Okay, next one we're going to look at is a trinomial. So a trinomial, again, the base tri means 3, so that's going to be what's called a polynomial of 3 terms. We'll talk about, again, what those polynomials mean. Just know the base bi means 2 and tri means 3. So some examples: x squared minus 3x plus 2. X squared is a term, negative 3x is a term, positive 2 is a term. On the next one, p cubed plus q squared plus 6. P cubed is a term, positive q squared is a term, positive 6 is a term. Okay, so there we have monomials, binomials, and trinomials. Okay, so just an overview before we move on to polynomials. So there's special names for polynomials with 1, 2, or 3 terms. So monomial 1 term, binomial 2 terms, trinomial 3 terms. So you can think of a monocycle, aka unicycle, bicycle, tricycle. That tells you how many wheels are on it. We also have things called a quadrinomial, 4 terms, and a quintinomial, 5 terms, but those aren't used very often. Typically anything above 3 terms we just straight up call a polynomial. Okay, so polynomial is a monomial, or the sum or difference of 2 or more monomials. Okay, so we're looking at adding or subtracting 2 or more monomials, or just a monomial by itself. Okay, so some examples. 3y squared plus 5y plus 6. If we do our terms, we see that this guy has 3 terms, so that is 2 or more monomials added together. The next one, we've got 3x to the 4th plus 5x squared minus 7x plus 1. So if we do our terms, here we have 4 terms, so we consider that a polynomial. All right, so now let's talk about degrees of monomials. Okay, so a degree of a monomial is the sum of the exponents, so sum means addition, sum of the exponents of the variables. So we're just strictly looking at the exponents on the variables, not on the coefficients of the monomial, and they must be whole numbers, so that's counting numbers and 0. Okay, they got to be whole numbers. They cannot be negatives. Okay, so let's take a look at some examples. So the first example is 5x. Well, the variable is x. If I don't see an exponent, that means its exponent is 1. So that means the degree on here, we can say degree equals, or d equals 1. Okay, for the next one, we've got 6x squared y cubed. So I see 2 on the x squared and 3 on the y cubed. I add those together, and I get that my degree is 5 for that monomial. Right? The last one, 2p to the 8th, q to the 10th. I see an 8 exponent and a 10 exponent. We add those together, and the degree here equals 18. Okay, again, you can use d or degree. Okay, so taking a look at some non-examples of when you can't find the degree is when we have negative exponents. Okay, so I have a negative exponent here, a negative exponent here, and this is the same thing as x to the negative 1, so it's a negative exponent. So we cannot have a degree with negative exponents. Okay, they have to be whole number exponents. Okay, so now we just talked about the degree of a monomial. We're going to now talk about the degree of a polynomial. Okay, so when we're looking at, when we're looking at degrees of polynomials, okay, what that means is we're taking the highest degree of any term in the polynomial. Okay, highest degree of any term in the polynomial. Okay, so we're not adding the degrees between terms, we're taking the highest degree that we see. So we'll take a look at this example. The term, or the degree of the first term that I see here is 4. So that means that degree is 4. This term, I see an x squared, its degree is 2. This term, I see a x to the first because it has no exponent, so that degree is 1. And because there's no variable here, that means it is a variable raised to the 0 power, which means that its degree is 0. So when I'm taking a look at this, that means I'm going to take the degree of the highest exponent that I see, and here I see that the degree is 4. Okay, so in the above polynomial, we looked at the individual terms. The degree of the polynomial is the same as the degree of the monomial with the greatest expression. Okay, so they are the same thing. You find the monomial with the greatest exponent, or the greatest degree, and that's going to be your degree. So the degree of this expression here is 4, okay, of that polynomial. Okay, so let's take a look at this example here. I see a degree of 5 in the first term, a degree of 2 in the second term, a degree of 1 in the third term, and this has a degree of 0 because there is no exponent. So because my highest exponent, or my highest degree is 5, that means of the polynomial, the degree is 5. Okay, next example, I see 2y squared plus 6y to the 4th minus 8y minus 4. The first degree is 4, the first degree is 2, the second degree is 4, the third degree is 1, and the fourth degree again is 0 because it's a constant. So the degree of this polynomial is 4. All right. Just get those examples. Let's go ahead and take a look at what standard form of a polynomial is. Okay, so when we're talking about standard form, it's the form of a polynomial that places the terms in descending order by degree. Okay, so that means we are figuring out the degrees of each of the terms, and then placing them in descending order using the commutative property. So taking a look at the first example, I see that this one has a degree of 2, and this one has a degree of 1. So I want to put them in order from greatest to least. Okay, and currently they are already in order from greatest to least, so this is already in standard form. The next one again, I see 8x to the 5th, so that degree is 5, negative 2x cubed, so that degree is 3, and then plus 3, so that degree is 0. We see that the degrees are in order from greatest to least already, so this polynomial is in standard form. Okay, so if we're putting a polynomial in standard form, we have to start with the largest monomial in terms of its degree on the left, and then we decrease in order from left to right. So my first term here, its degree is 7. My next term, its degree is 0 because it's a constant, and the last term, its degree is 10. So we want to put them in order, again, greatest to least. My greatest degree is 10, so I'm going to take that term, the sign and the number. That's negative 9x, or 9x to the 10th. Then my next term is negative 17x to the 7th because it's the next smallest degree. And then my last term is plus 5 because its degree is 0. So this would be the standard form of the original polynomial. Don't forget to take the sign in front of every term. So like here we had a minus 9x, we take that as a negative 9x. All right, so now we're going to move on to adding and subtracting polynomials. Okay, so we can add and subtract polynomials by combining their like terms, which is a topic we have already gone over. Remember, like terms are terms with the same variable and exponent. So terms with same variable and exponent. Okay, terms with the same variable, same exponent. So let's take a look at example number 1. I see 12p cubed plus 11p squared plus 8p cubed. So I can take these monomials here and find their like terms. So I've got 12p cubed and 8p cubed, positive 8p cubed. And then I see that I've got in between those an 11p squared that's positive. So what I want to do is use the commutative property of addition. So I'm going to switch the 11p squared and the 8p cubed, rewrite it, 12p cubed plus 8p cubed plus 11p squared. Okay, and then what I can do is add my like terms now. So I'm going to combine these guys together, and I get 20p 9p cubed plus 11p squared. And the final thing is I check to see, so here we use the commutative property. And then the last thing I do is I check to see if this is in standard form. So is it in standard form? If the answer is yes, which it is here, we get to then say that that is the simplified polynomial. Okay, let's look at the next example. Okay, so 5x squared is a like term, or is a term. It has no like terms here. I see -6, which is a like term with +8, and then -3x is not a like term with anything, so we're going to use the commutative property to change the order of the -6 and the -3x. Again, make sure that you use the commutative property and you take the sign in front of the number. We're going to rewrite it as 5x squared minus 3x minus 6 plus 8, and then combine the -6 plus 8 to then get 5x squared minus 3x plus 2. Again, we check for standard form. And if it's standard form, which means it's in order by descending degree, this degree is 2, this degree is 1, and this degree is 0. Because it's in standard form, that is the simplest polynomial that we can get. Okay. Now, typically, these aren't the types of problems you're going to see. They're relatively easy. This is combining like terms like we talked about in our very first lesson this year. You're typically going to see more problems similar to this, where you've got two polynomials in parentheses and you're asked to either add or subtract them. So we're going to talk about two different methods today. We're going to talk about the horizontal method, and in this horizontal method, it uses the commutative property. And we're using the commutative property to rearrange the numbers, okay? The first step that we're going to do, step 1, is we want to ignore the parentheses when we have addition. Okay? The parentheses aren't useful here because there's nothing to distribute. If you have a +1, that keeps everything the same. So step 1 is we ignore the parentheses because there is nothing to distribute, and then we just can rewrite the problem without the parentheses. Okay, after that, step 2 is we're going to locate like terms. Okay, so from my step above, I have 2x squared and positive x squared as like terms. And then I also have -4 and -3 as like terms. And then this plus or positive 3x is not like with anything else. Okay, so once we identify our like terms, our third step is we're going to rearrange using the commutative property. So we're going to put the like terms next to each other by using commutative properties. So we'll write 2x squared plus x squared. We use the commutative property here. And then plus 3x because it's not a like term with anything. And then -4 minus 3. So that's us rearranging with the commutative property. And then the last step, step 4, is to combine like terms. Okay, so we're going to combine like terms. We see the 2x squared and the x squared. That will give us 3x squared because the coefficient here is 1. The 3x is not a like term with anything, so we bring it down. And then -4 minus 3 is -7. Okay, we always, again, want to check to see if it's in standard form. Okay, my degree here is 2, my degree here is 1, and my degree here is 0, so it's in standard form, which means this is the simplest polynomial after you add the two polynomials. Okay? So the vertical method we'll talk about next. It is similar It looks very similar to adding large digit numbers in elementary school. So similar to adding multi-digit numbers from elementary school. Okay, very, very similar. So we'll take a look at that. So the first step is we're going to stack the equations. One on top of another. And when you're stacking equations, you need to make sure you line up the like terms, okay, and then fill empty spaces, so that's numbers with no like terms, with placeholders. Okay, and those placeholders are going to be 0 as the coefficient with whatever variable you're talking about. So for the first example, we're taking 2x squared, and then next to 2x squared, we're going to write plus 0x because it has no like term in the first equation with 3x here. And then minus 4. And we'll stack that on top of x squared from the second polynomial. And then plus 3x from the second polynomial. And then minus 3 from the second polynomial. Okay, once we do that, after step 2, or after step 1, step 2 is to draw your line and add. Okay, so step 2, draw line and add terms. Okay, so we're just going to go straight through and add our terms. So we have 2x squared and x squared, that's 3x squared. We've got 0x and 3x, so that's still 3x, and then negative 4 and negative 3 gets us negative 7. Always we check for standard form, so is it in standard form? We look at our degrees. I have a degree of 2, a degree of 1, and a degree of 0. So because it's in standard form, that would be our simplest polynomial. Okay, subtraction is very similar. So we're going to take a look at using both methods with subtraction now. When we're using the commutative property for the horizontal, we do not ignore parentheses here. So step 1, we need to deal with the parentheses because they have a minus sign, which we can count as a negative out front, which means we need to distribute a negative 1. So we're distributing that negative 1 to every term. Inside the second set of parentheses. Distribute the negative 1 to all terms inside the second parentheses. Okay, so that means the negative 1 goes to all of the terms. Once we do that, we can then rewrite the polynomial as 2x squared minus 4. So the first set of parentheses just leave, they're irrelevant, and then minus x squared, which is minus 1x squared, which is x squared, minus 3x plus 3. Okay, once we do that, step 2 is to locate our like terms. Okay, so I see 2x squared and negative x squared. I see negative 4 and positive 3, and then I see a negative 3x by itself. So that's us locating our like terms. After we do that, our next step is to rearrange using commutative. So we're going to put the like terms next to each other. So we have 2x squared to start with, and then we're going to subtract x squared. Then we're going to have minus 3x, because in descending order by degree, and then minus 4 and minus 3. Minus 4 and plus 3. I almost said minus 3. Once we do that, the fourth and final step is to combine are like terms. So I have 2x minus x, which gets us 1x squared. Simplified, I can write that as x squared. The minus 3x has no like terms, and then negative 4 plus 3 is a negative 1. Again, we always check for standard form. So is it descending by degree? The degree of the first term is 2, the degree of the second term is 1, and the degree of the last term is 0. So it is in standard form, which means this is my simplified polynomial. Right, the vertical method, again, is similar to subtracting big numbers in elementary school. So it's similar to the addition method, except for we're subtracting. Typically, what I like to do first here is I like to distribute the negative 1 first. Okay, and then when I do that, that turns the problem to an addition problem. Okay, so I distribute the negative 1. When I do that, I still have 2x squared minus 4 in the first set of parentheses, and then I'm adding a negative x squared minus 3x plus 3 from the second set of parentheses. After that, I then go ahead and I stack my polynomials. Okay, so I'm putting, again, 2x squared first. I need a placeholder for the x's since the first polynomial does not have any x's. And then minus 4 second or third. The next one I have negative x squared minus 3x plus 3. Okay. Once I do that, the third step is to draw the line. And then we're going to add, because I already distributed the negative sign, the minus sign, so we're going to add. Once I do that, I end up getting 1x squared, which is just x squared, and then minus 3x, and then minus 1. Again, I check for standard form. I see that it is by degree of polynomial, so I've got a degree of 2 here, degree of 1 here, degree of 0 here. So that is the simplified polynomial. It does not matter to me if you use horizontal method or vertical method. It's really whichever one's easier for you. When you pick your preference, you've just got to be careful to make sure that if it's subtraction, you're distributing that negative. And then when you're combining like terms in the horizontal method, you need to take the sign and the number, not just the term by itself without the sign in front of it. Okay, so you're going to move on to practice. Please let us know if you have any questions.